Okay, so let's actually build a confidence interval for a difference in proportions. Okay, so we just checked the conditions earlier, right here. And so now we're saying when conditions are met, an approximate C% confidence interval, 95% usually, for p hat 1 minus p hat 2 is this. Ooh. That seems like a flaw. This should really say P1 minus P2, right? We never want to estimate or build a confidence interval to estimate sample proportions. No, we have that. So that seems like a flaw in their little box there. Any case, so here's the formula. So it's the middle of the interval, which is P hat 1 minus P hat 2 from my sample proportions. Plus minus z star, again proportions or z procedures, and then just times the standard deviation of the difference of the sampling distribution of the difference in proportions. Okay, so this is the center of the sampling this is the center of our confidence interval, and this would be the standard error, actually not standard deviation, the standard error of the difference in sample proportions. Okay, and so that's basically it. Just remember, this is not on your formula sheet. This formula is approximately on your formula sheet right here, but the confidence interval formula definitely not. It's just more generic. Okay, so let's read this. It says, as part of the Pew Internet and American Life project, researchers conducted 2 surveys in late 2009. The first survey asked a random sample of 800 US teens about their use of social media and the internet. Second survey posed similar questions to a random sample of 2,253 US adults. In these 2 studies, 73% of teens and 47% of adults said they use social networking sites. Use these results to construct and interpret a 95% confidence interval for the difference between the proportion of all US adults, teens, and adults who use social networking sites. Woo, lots of stuff going on here. Okay, so I think what we want to do is say, let's call this N1, let's call this N2. Okay, sample size 1, sample size 2, and this is teens, so N1 is teens, so then we'll have to call this P hat 1, and we'll have to call this P hat 2, okay, because from the 2 studies with the 2 samples, I got these 2 sample proportions, and we want to make a 95% confidence interval. I think that's all we need, so we can just do our same 4-step process. State, we want to estimate P1 minus P2 at 95% confidence level, okay, estimate P1 minus P2. So P1 would be the true proportion of US teens who use social media minus the true proportion of US adults who say they use social media. Okay, so we have to define this. So we have to say where P1 is the true or population proportion of US teens who said they use social media. Not said, actually, sorry. Not said. Said would be the sample, who use social media in reality, okay? Not who said. Said is the sample. And then here we would have P2, which would be the true proportion of US adults who use social media. Okay, and then so we did our state part. We said what we're gonna do. Then of course we need plan, and so we say if conditions are met, we will calculate, construct either one, now to sample z interval for P1 minus P2. Okay, so again, this is a formal name of a procedure to sample z interval. All right, on your calculator, guess what? It's going to be called to prop z interval. But hey, here we are. We're dealing with proportions. So random. Check our conditions. Random. What did it say? Both samples are random samples from their populations. So you just say both samples are random samples from their respective populations. Okay, and then normal condition here, large counts condition, because we're dealing with proportions, and we're checking large counts for both sampling distributions. So we're doing n1 p hat 1, which is 800, that's my n1, I think we said that, yeah, times p hat 1, which is 0.73, which is 584. That is greater or equals to 10, okay? And then we're checking n1, 1 minus p hat 1, which again is 800 times 0. What would that be? 26, okay? And that would be equals to 216, I think, if you do that calculation, which is greater or equals to 10. All right, good. So the first sampling distribution meets the large count condition for the first sample, and then second one, n2 p hat 2, which would be 2253 times 0.47. And that ends up being 1058.91. Don't round this, you'll be tempted, but oh, I think actually, do we round it? I think actually the calculator, if you do this kind of stuff, actually rounds it too. So we can make this 1059 greater or equals to 10, because obviously we can't have half individuals. That doesn't really make sense. And so we have 2253 times 1 minus that, which would be 0.53. Okay, and if you do that, I think you get 1194.09. So we'll round this one down so that we don't exceed our sample size, which is greater or equals to 10. All right, so I would just do this if I were you. The easiest way to write this, the normal condition is met. Okay, don't want to start talking about the sampling distribution of the difference in sample, that's going to get you messed up. So I think that's the easiest thing to say. Okay, in case you start forgetting this stuff later. And then independence. So 10% condition. So here's my question. Are the two samples independent? So I randomly selected 800 US teens and then randomly selected 2,253 adults. So do I have any reason to believe that those two samples are interfering with each other or somehow not independent of each other? Hard to imagine that. So we can just say something like it is safe to assume the samples are independent of each other Okay. And it is safe to assume that there are more than, what do I need to beat here? 8,000 US teens and 22,530 US adults. So the 10% condition is also met. Okay, so we did between samples, and then within the samples, individuals should be independent because we sampled less than 10%. All right, so then last step here would be to actually do the do calculation now. Conditions are met, we seem satisfied. So we do p hat 1 minus p hat 2 plus minus z star times the standard error, which is p hat 1 minus times 1 minus p hat 1 over n1 plus p hat 2 1 minus p hat 2 over n2. Okay, and then we just substitute things. So we say what was our p hat 1 was 0.73 again, so 0.73, p hat 2 0.47 plus minus 95% confidence interval for a Z procedure. We've got this one memorized, 1.96, and plug stuff in. So 0.73 times 0.27, and our first sample size was 800 plus 0.47 times 0.53 over 2253. And I think if you do that calculation, you end up with 0.223 to 0.297. Okay, I'll have to go check that on the calculator, but I'll make a tutorial again for you on how to use the calculator to do this. Very important. It is described back here. And I think, is that right? 584. Yeah, I think that's right. What was our interval? 223 to 297. It looks like the numbers here correspond with what we just wrote. So, in any case, sometimes we do it manually, sometimes they did it using the test. I can't remember what I did when I made the notes, but this looks correct. So I'll go over the calculator thing. But remember, we have to conclude, because the question said this. The question said, construct, we've done that now, we have the confidence interval, but interpret. Interpret is our conclude step to a inference procedure for a confidence interval, okay? So we are 95% confident that the interval from 0.223 to 0.297, okay, and I shouldn't write it like that. I should probably write it like this. Of course, you can't do this kind of trickery. I should probably write it like that. From there to there, okay, contains or captures the true difference in proportions of US teens and US adults who use what did it say? Social networking sites? Yeah, social networking sites, okay? Social media, social networking sites. All right, I hope that's okay for you guys, and like I said, I'll do a calculator tutorial for you right after this.